Welcome to this video lecture. I am Dr.SHRIRAJ and I will be presenting a lecture on environmental effects on durability of composite materials and structures. It comes under Module 5. In Module 5, one of the most important question is on thin laminated plate theory. It is also known as governing differential equation of thin laminated plate. The second important question in the Module 5 is on environmental effects. The question could be in this way: discuss how environmental effects can influence long-term durability of composite structures. Composite materials and structures generally in contact with external environmental conditions such as ground environment and in space environment. Ground environment encounters corrosion, moisture diffusion, foreign object impact. Space environment encounters radiation and thermo-vacuum environments and MITE environments. Ground environment affected by temperature and humidity. Corrosion of composite involves chemical deterioration or due to physical deterioration. The meaning of chemical deterioration is weakening of chemical bond due to the reaction with corrosive agents, and the meaning of physical deterioration is swelling or expansion of polymer that is due to the absorption of moisture by the constituents of the composite. Gaseous environments or gaseous reactants include oxygen, chlorine, carbon, sulfur. These are rich in ground atmosphere. For example, in case of metal matrix composite, this metal matrix form metal oxide when in contact with oxygen. But in case of ceramic, something like Al2O3 alumina or silica SiO2 or titanium oxide, these are all a few examples for a ceramic material. These are stable at high temperature and they exhibit good oxidation resistance, and they exhibit good corrosion resistance. Aqueous environment, water is the corrosive electrolyte which is causing all common types of corrosion. Oxygen dissolved in aqueous solution can initiate or start corrosion at the surface of the crack or at the joint location of the composite. Small pit formation or hole formation appears in specific locations where the protective layers are eroded or worn out because of aggressive anions. This may lead to a corrosion called pitting corrosion. If marine hull is made up of composite, it may undergo a galvanic corrosion. Galvanic corrosion is observed in seawater where chlorine content is high. The stabilizer of F16 uses non-conductive layers between aluminum truss core and graphite epoxy skin. When two dissimilar material of different electric negativity brought in contact and in presence of electrolyte, there can be formation of electrolytic cell that leads to galvanic corrosion. So the whole objective is to avoid galvanic corrosion, which is possible by avoiding a direct contact between a dissimilar material having difference in electric negativity. In addition to above discussed types of corrosion, there are other possible types of corrosion experienced in composite, that is combined effect of fatigue load and corrosive environment, synergic effect of stress and corrosive environment. Hydrogen embrittlement means diffusion of hydrogen into material. Here it is composite. As a result, the material is converted into brittle. You know, brittle material always susceptible to cracking. Because of diffusion of hydrogen, your material is converted into brittle, and because of brittlity it induces cracking, and this is also one of the possible type of corrosion. Some of the important observation made on composite material corrosion. First we will see a fiber, carbon fiber and glass fiber undergoes corrosion when in contact with carbon monoxide and carbon dioxide vapor. Coming to the corrosion of the matrix material, that is thermoplastic, exhibit good oxidation or corrosion resistance, whereas thermoset undergoes corrosion. As a result, the mechanical property of the thermoset composite get reduced. The factors such as fiber matrix debonding, narrow crack formation, plastic deformation, a cluster of elements known as segregation of elements, and residual stress, they are the main factor that influences corrosion process. Blistering is nothing but bubbles on surface. As you can see here, blistering is bubble on surface or a raised area in molded part, which is observed in a polyester resin composite which is used for making boat hulls. Blistering have significant impacts on the durability of the composite. There are various causes for blistering. We will see one by one. First one is osmotic effect, difference in solute concentration within the composite that creates osmotic pressure. Osmotic pressure, it is the pressure at which the flow of solvent into the solution through semi-permeable membrane is prevented. Observe this here. The solvent H2O and NaCl that diffuses across a membrane or gel coat. So as a result, there is a raised area or bubble or blister formation. The other causes for blistering is due to trapped gases or liquid. When it is subjected to heat, these trapped gases or liquid, they may expand, as a result causing a distortion to gel coat. Blistering, speed of material breakdown. It accelerates breakdown of the material or degradation of the material. The second aspect of ground environmental effect is moisture diffusion. Moisture diffusion, it is a process where water molecules are absorbed by polymer by the formation of hydrogen bonding. This behavior is observed when polymer composite is in contact with air and air has high moisture content, or it is in humid environment, or composite which is submerged in water. There are various factors that influence moisture diffusion. To name a few here: temperature, humidity, surface area of the composite or surface area of the polymer exposed, resin and fiber properties, and even a crack or void that can accelerate the moisture absorption. The third factor in ground environment is foreign object impact. Impact means here collision among two elastic bodies. One is a target, which is most of the time composite, and second one is striking or impacting objects. Usually the mass of striking object is less than the target object. You can see here bird strikes an aircraft engine, fans and blades. The second example is hailstone. In Kannada we say as alikallu, small but hard ice balls which falls from sky and hit aircraft wing. Another beautiful example you can see in ice hockey games. Hockey puck, which is a round object that hits hockey stick. This is made from composite. As a result, a puck bounces off the stick. Another example for impact events: falling of hard objects like tool or bolt which results in fatigue cracks. Additional example could be bullet hitting a bulletproof vest or jacket, which is made of composite. Now we will see a space environmental effect on durability of composite. Space vehicle has to face environmental challenges either during flight or in orbit, such as radiation, thermovacuum conditions, meteoroid impacts, in Kannada as Ulke. Radiation resulted from high energy protons, electrons, solar rays, galactic cosmic rays, GCR. These damage space vehicle. Galactic cosmic rays is nothing but high energy particles originated from outside of solar system, like supernova, neutron stars. All these damage space vehicle. In vacuum condition, polymeric materials releases gases, vapors, volatile components, which are known as outgassing. The thermal stress can also occur with composite structure. The combined effect of outgassing along with the thermal stress is observed in thermovacuum environment. First impact of radiation could be cross-linking of molecular chain. You can see here the cross-linking of one molecular chain with the another. The second outcome is due to breaking of polymer chains into smaller segments. It is found that because of radiation effect, the Young's modulus, the strength and hardness of the composite decreases, whereas elongation, also known as strain, thermal conductivity, that increases. The second factor in space environment is meteoroid impact. Meteoroid are nothing but solid particles. They are originated from comets and asteroids. These meteoroid imposes some problem on space vehicles. To what extent it creates problems, that depends on the size of the meteoroid, velocity of the meteoroid and impact angle of the meteoroid. Meteoroid, in Kannada we say as Ulke. Comets, Kannada we say as Dhumaketu. Asteroids, Shudra Grahagalu. Meteoroid environment could be region around sun where comets, that is ice bodies, are found. As comets approaches sun, they heat up and releases gases and dust. Debris are small fragments of material that has been blasted off moon surface due to meteoroid impact. We call this as lunar ejecta. Another region where meteoroid environment could be asteroid region, which is located between Mars and Jupiter. These asteroids are nothing but rocky bodies made up of metal or mineral. Meteoroids observed to be porous and they are fragile. The meaning of fragile is that can be easily broken, and the size ranges from a grain scale to meter, and it is made up of dust particles which is surrounded by frozen gases or ice. If meteoroid hits a target which is made up of a composite in the velocity range above 3000 meter per second, it creates shock pressures, As a result, there can be heating effects. Due to this, the composite material may undergo compression, fracture and heating due to shock. As a result, the material may melt or what we say as fuse, and finally it may lead to vaporization. The damage can be catastrophic. The meaning is brittle failure without any warning. No warning of failure. The response under impact events depends on composite material composition, thickness and the type of composite, whether it is a laminated composite or sandwich type, and the temperature, in addition to meteoroid characteristics. The most likely question from these environmental effects could be of this type. Discuss how environmental effects can influence the long-term durability of the composite structures. Other way of asking the same question: which are the important degrading effects of temperature and moisture on polymer composite? The same question could be asked in another way: describe the effects of ground and space environments on composite materials and structure. Sub question which could be asked from this topic: what is blistering and how it is formed? Thank you for listening.